More examples about scatter diagrams is what we are going to see in this lesson. Please don't forget to subscribe to the channel. Now, this question they are giving us that draw a scatter diagram for the maths in the table below. They are giving us here E and then the act. These are the maths as you see there. Then part B, draw a line of base fit for the data. And then in part C, find at when here E is 30. Now here, simplify work because we want to draw a line of base fit. Say we need the midpoint. The midpoint is x bar, then y bar. Those are the coordinates. But now, plot, I think plotting like we saw in the first lesson, plotting is very easy. But I'm going to concentrate on how we did our scale. Now, when we look at the CRE marks, I said let x be represent CRE and y represent at. So that CRE, the highest mark we have here is 90. But the smallest bit is 20. So meaning, how am I going to start my scale? It means that I can get 10, 10, the scale of 10, 10. But because I have the smallest as 10, that's why I must subtract 10 from this. And then I start at 20 as my first value on the horizontal for CRE. Instead, you name the axis. This is for CRE, then this is for at, as you see. Then my starting point is going to be 10 so that it covers the smallest value, which is 20. Then minus value is 90. That's why you see I'm ending at 100 so that I'm covering that. When I come to the vertical where we have at, my smallest figure is 55, but the highest is 95. Now here, you don't need to start with the 10 because it's an array you have. You see, it can be from 50 then to the highest, which is 9, so you can come up from 100. So now here, to draw a reasonable graph, you have to start at the scale rose to 55. The smallest, always just the starting point should be very close to your smallest value. That's why here now, I'm starting at 50 so that I can have a reasonable scale. I can start from 10. Why? Because that these values now 50, they will be on the side, which the graph will look funny. That's why here the smallest was 20, I'm starting with 10, but here the smallest is 55. Now I'm starting with 50. So there's no need for you to start from 10 here because you end up with such graphs. You end up with a graph when you have all the data points decided when decided is nothing. So that's why I'm drawing. If I have the smallest, the starting value should be from this one. So I can't start from here, I can't start from 0. Why? Because if I start from 0, here I started from 0 to 55, that would be the difference will be 55. Yet from here to here is the 5, which would be a very fixed scale. That's why the scale we said should be from here to here 5, from here to here 5, from here to here 5. Yet here, from here to here is 10, from here to here is 10, from here to here is 10. So the scale on the horizontal is uniform, and also my scale on the vertical is uniform. Here I'm using 5, 5 for every 2 centimeters, while here I'm using 10, 10 for every 2 centimeters. That's why I find my scale. So 2 centimeters for every 5 marks on the scale. Now, you need to know what is small square. Those small squares in those centimeters are. Remember, every 2 centimeters add in 10 small squares. Meaning, if I divide through 2 centimeters for 10, but still this 5 is there, divide through by 10 by 10, means every small square. These are what I mean with small squares. I'm using 2 centimeters, so these are 2 centimeters. So there are these small squares here. So it means that every small square here is 0.5. When it comes to the horizontal, these are 2 centimeters. 2 centimeters are equal to 10. What about, remember 2 centimeters are having 10 small squares. They are already stamped in 2 centimeters. So what about 1? It means that every small square is having 1 mark. These are helping us when we are computing. So that's how we define the scale, as simple as that. Okay, now plotting I think is very easy. You plot pair. So 35 and 90. You come here, because from here up here is 10, it means that the middle part of this is going to be 15, 20, 25, 30, as simple as that. So it means that now, if I want 35 is in between 30 and 40, the middle part. Then I want the at, I have 90. That's why you see my 35 and my 95 is here, not here. It's supposed to be here, not here. So sorry for that. That's where I have my 35. Yeah, my 35 is supposed to be there. I think I missed the point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I missed the point. So then when I come to 65, 65 is here. It goes with 70, as you see. My 65 goes with 70. So 65 is here. Then I come to 70. You see where my 70 is? My 70 is there. When I come now to 55, it goes with 80. 55 is here. It's between 50 and 60. It goes with 80. Where is 80? You see it's there. When I come until when it reaches to 60, where's my 60? 60 is here. Then 80, 60 and 80. You see, that's the value. So project I think is very easy. Now when we come to the line of best fit, it's like the line of best fit, all people call it, some people call it the regression line. We say you need X bar, then Y bar. How do you get X bar? Now we say that these are the CRP max. We say the X is representing CRP. You get X bar, you add these ones, as you see, then you divide by their number. How many are they? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's why I'm dividing in the 10. And you complete this to get 520 over 10, it will give you this. Then when I come to the add, which is Y, you add this as you see, add them, then they are total, divide by their which is 10. So you add this, you get 790 over 10, which will give you that. Now you come and you plot this one. Why? Because we say the line of best fit should pass through this midpoint. So now, you see, I made 52. So I have here 50. I'm using now my scale on the horizontal. It means that every small square is representing 1. So if this is 52, 50, if this is 50, I need to add a 2. So I'm going to count 2 small squares. So this is 1, then this is 2. So this is where my 52 will be. I'm starting with the X bar, the one on the CRP. That's why I'm having 52. Then I come to 79. 79, but you say on the vertical, each one small square is representing 0.5. So where is my 70? My 75, you see that 79 is about 75. So start from here. So how many small squares do you need? You see that from 75 to 74, there are 4 small squares. What you do, you just say how many small squares you get. You get 4 divided by 0.5. And so this will give you 8. So from this now, you count 8 small squares. 1, 2, 3, 4, 5, 6, 7, 8. So that's where my 8 will be. So that's how we can easily know how many small squares we count using our scale. So now from here, I'm going to count now. This is my 79 and then 52. So they are going to meet around here. That's where they are going to meet. If I want to put it there, this one is here. And what about this one? Exactly there. So this is that. So I'm going to put a dot there. Then I put this is. Now you name it. You name it. It's going to be my 52, 79, the mean point. The mean point. Then from there, you need to draw a line of the skid, pass it through there. So if I'm to draw that line of the skid, passing through there, I think mine, you see, this is going to be my line of the skid. At least it should pass through some point. So from here, it's going to pass through this point, then this point. So I'm to draw my line of the skid. That's how it's going to be there. So this is my main point, and you can easily see this was our point, also this was a point. We have project. So that's my line of best fit. Clear. Now what next? Next part they are telling us that find at when Sarah is 30. So here is our CRE. When Sarah is 30, so we have 30, this is where we are. When I have 30, I'll come there, then I come here, I join 30 to the line of best fit. We use line of best fit to know. So when I get 30, they want me there, I want to meet if 30, remember, when we have CRE, we are having the max for art. Now, we have the CRE at 30. I need to get now what are the max for art. So when 30, you do it. When that is the line of the seat, then you come and you read off in the value there for y. That will be the value for art. So now I read off this value. What you need to do, you just need to count how many small squares are here. So it's like when I count, here I'm having 1, 2, 3, 4. So there are 4 small squares. But each small squares, so 4 small squares, it means but each is 0.5. So it means we are going to get 4 and 0.5, which will give us 2 marks. So it means that now from 90, I add 2. So when when CRE is 30, our art is going to be this is 9, then plus this 2 got from here, which will give me 92, and that will be the answer. So that's it, members. Unless you have a question, you can leave it in the comment section. Now this one is saying we are going to see similar correlation. That this one is called a negative correlation, as you're going to see. That's it. I wish you